All right, so that did cut me off, so let me go back, and we were trying to balance the nuclear equation here, number 4 and 5 examples from the notes. All right, so what I was saying was that there are 2 reactants here and 1 product. So the total subscripts on the product side is just 195. Let me zoom in on that because that's kind of hard to read. So 195 plus what equals 195? Well, obviously, it's a 0 that goes up top. 195 plus 0 is equal to 195. On the bottom, 79 plus what equals 78. Okay, now remember, in order to get a 78 over here, it must be a negative sign here. So negative 1 plus 79. So 79 minus 1 equals 78. So what you want to do now is figure out which of your emissions matches the mass and the charge here. Now there's only one of our emissions that has a negative charge, and that's your beta particle. So that's what you're going to put there for your symbol, 0, negative 1, E. So this would be considered a beta capture. As opposed to, like on number 3, this was releasing an alpha particle, so you call that an alpha emission, or alpha decay is what it might be referred to. And number 2, that was also an alpha emission because notice that's released as a product. And on number 1, notice, find your yield sign, the beta particle was a product, so that will be called a beta emission or a beta decay. Just trying to go through some terminology here with you. All right, number 5. Pause the video and try to do number 5 on your own and then resume. I'm going to keep going just because of time sensitivity. All right, so this is your equal sign again. So there's one parent nuclide, and this is giving you the daughter nuclide, and you're trying to figure out what the emission is. So we have 38 equals 38 plus what? So obviously this is a 0 on top. 38 plus 0 equals 38. Now look at your subscripts. 18 plus what equals 19? Well, 18 plus 1 equals 19. Now, this is not going to be the element hydrogen. This is going to be an emission. So let's take a look at our emissions and see if there's one that matches up that has to have a 0 for the top number for our superscript. And so we have the beta particle, but look, the subscript is wrong. And then here we have the positron. Notice the positron is a 0 as your superscript and a 1, in this case a plus 1 for the subscript. And that's what we have here. So understood plus 1. So that's your positron. So this will be called a positron emission or decay. All right, so balancing nuclear reactions is pretty simple to do. You're just going to be using your periodic table. Now, I know on these examples that we've done here, it was an emission, but if you call back in the first 2 examples I did, the way that we figured out what the daughter nuclide was is you look at your atomic number on bottom. So we said, like for number 1, the atomic number was 30 when we figured out our numbers, and atomic number 30 is zinc. That's how we identified the daughter nuclide as zinc. And then with mercury, here we knew that 2 plus 80 equals 82. So we had to figure out, well, who is element 80? And so that had to be mercury here. Okay, so you'll need to have your periodic table handy to do these. I also want to remind you of the penetrating power of the emissions. I know that you guys copied that down in a section of your notes, but let me just remind you of the penetrating power of the emissions. And to do that, I'm going to look at a little video clip or an animation for you for that. Here you have a piece of paper and a piece of metal, thin metal, and a piece of lead. And there you have your alpha particle. your beta particle, and your gamma ray. Notice it travels as a wave. Alpha particles are the biggest, so they can get knocked down by a piece of paper, like a piece of paper would protect you. The beta particle is smaller, it goes through the paper, but the aluminum, is not able to get through the aluminum. Gamma particles are the most penetrating. It would take several inches of lead to protect yourself from a gamma ray. All right, that'll be all for this video lesson. We will take a look at half-life calculation